Hello, I'm JW. This time we're going to have a look on these Wago and the other kind of connectors again. We're going to actually test some of these outside and shove a load of current through and see which fails first, if anything. But before that, a couple of points which were raised on the comments, so just answer those before we actually go outside. Now, someone on the comments did ask about these things, whether they were attracted to a magnet, and we can find out. So here's the actual Wago one on the right here, and this is the other brand on the left, and as we saw before, it's just the fact that one's cut all the way through and the other is not. So here's a magnet here. That one, as you can see, definitely attracted there. And the Wago one, well, as before, it's attracted as well. So they're certainly made of some kind of ferrous material, presumably spring steel or something. But as you can see, they're both attracted to the magnet in the same way. So those are basically the same. Now, another comment was, are these made of the same kind of plastic or not? And I've got the two here. This is the Wago one, obviously, with the Wago marked on, and this is the other one. I've already had a hack at it with the tool here. So we'll just cut this and see if it actually sounds the same. So I'll just try that again then. So again, this is the Wago one first. Let's go on the front there. So that was those two. It's not easy to tell really if there's a huge difference. And if you look at these, the Wago one here does seem to be a bit more smoother type of plastic. This seems to be a bit more sort of granular and possibly scratchy. So maybe some difference in the plastic there, but nothing that's terribly obvious. And as was pointed out in the other video, one of them is actually marked PA66 in the bottom, and the other one is not. But other than that, they look, again, pretty much the same. Now for the first test, we're going to apply a flame to these and see what happens. Now we're doing this outside, obviously. Unfortunately, it's a windy day, and also the sun keeps going in and out as well, so the lighting might go a bit wrong on some of these, but that's just how it is. Now, if these things actually burn, what should happen is that when the flame's removed, they should self-extinguish. So just applying the flame there to the Wago one. And we see the plastic's melting there, but it's not actually burning or setting on fire. Bit of smoke coming off, but you notice when the flame is removed, it basically just solidifies back again, and there's no actual burning involved. So that seems perfectly acceptable. Now we'll do the same to the Wago brand on the left there, and first pressure there, it seems to be doing the same thing again. So it's just sort of melting, a little bit of smoke coming off, but no actual flame or continued burning once the actual flame we're applying is removed. So they seem to be pretty much identical in the way that they actually react, and obviously they're melting, but of course being like that's with a direct flame on it, they're not supporting combustion or carrying on burning after we've removed the actual flame there. And we see a bit of flame in this particular in part here, and that's basically the wooden backing being charred and actually burning. It's not actually the things themselves doing it, but even with that, again, once we take the flame away, it doesn't actually continue burning away there. So that seems pretty successful, and they react in the way you'd expect, and they both react in pretty much the exact same way. Now for the next test, we're doing the current, and what we've got here is two connectors there. We've got the Wago on the left and the questionable other brand on the right, so a little W and a question mark above it. Clamp meter there on the left just to show what current we're actually shoving through, and the wires here are 2.5 square millimeters, and these are copper. They did have insulation on, but I've removed all the insulation because we don't want that burning off and obscuring the result. And I've put two pieces into each connector, so we've got the equivalent of 5 square millimeters going in and coming out, and as they're wired in series, the same current will go through both. And I've got a timer here at the bottom left just so we can see how long this test goes on for. Now these connectors are rated 24 amps in this configuration with the 2.5 square millimeter wire. They can do up to 32, but that's only if you're using 4 square millimetre wire, and that has to be stranded wire. I don't have any of that, so we're just using the 2.5 here at the moment. So power's now turned on, and we see the current there is about 23.5 amps or so. This is basically at the rating of these devices, so you wouldn't expect anything to happen in this configuration. So just using that as a convenient starting point. So now I've cranked up the current to the next level, which is about 38 amps in this case. Now that represents quite a significant overload for these connectors, so we'll leave it running a bit and see if anything happens. So about 2.5 minutes in now, and nothing's happening there, so turning up the current even more, so now we're running at around 55 or so amps, or just slightly lower. And again we'll just leave this running and see what, if anything, actually happens. Now bearing in mind the wires here, in theory, are rated to about 26 amps each, so even though they're running about 55 amps, that's still actually within the rating of the wires. And you'll see they're not particularly discoloured or even showing any signs of overheating yet, so no problem there. And the connectors as well, again, nothing visibly changed either. So here at the 4-minute marks, and nothing visibly changed at all. So we'll turn up the current again to the next level, which is about 73 or 74 amps or so. Now it's 5 minutes, and again nothing visibly changed, so let's turn the current up again, and we'll turn up a few notches at once here, because we need to actually get something to happen. So current now is around 115 amps. And bearing in mind this is a massive overload compared to the 24 or whatever it's supposed to be rated at with these wires, but as you can see there's no sort of dramatic failures or flames or whatever coming out of it, so we'll leave it going and again come back in a few moments and see what's happened. So now just after 8 minutes, current's still about 115 amps, and you see the wires are starting to discolour in various areas. The sort of different golden and silvery bits are showing on the various parts there. Notable on the right there, we've got a bit of silver showing on that right hand connector. So it's certainly getting rather hot over there. But I think we'll just turn up the current again now to the next level. And this is pretty much as high as this thing will go. It's about 150 odd amps there. So hopefully something will happen this time. And we'll just keep leaving it on until something actually melts or fails. So this is 9 minutes, and the right hand connector is starting to melt, and it's not particularly visible there, a bit of smoke coming out, and it is starting to move slightly as the plastic obviously gets soft and starts to deteriorate. And that's the Wago brand. The Wago one on the left doesn't look any different at all, so that's pretty much as we started. And you note that pretty much all the wires now have discoloured in various areas with different colours of sort of purple and silver and various orangey bits showing through. So that connector over on the right is definitely getting extremely hot. You see it's sort of sagging down considerably, and there's a lump of molten plastic showing on the top of it. Smoke obviously appearing from within the connector there. Current still at this 150 amps, which bearing in mind even at the 32 amp rating is still 5 times more than it was actually rated for, so not too surprising that things are starting to fail. And there we see the connector has actually completely melted off of the terminals inside, but notable that the terminals are still holding and the current is still about 152 amps, so nothing actually has failed there. It's just that they've obviously got rather hot and basically melted off the plastic covering around them. Now we can see the smoke there pouring away from the connectors, which is just basically smoking away the remains of the plastic. So just well after 11 minutes now, so that's pretty much I think all it's going to be seeing there, so we'll cut off the current there and actually just disconnect the wiring completely and allow this to cool. And we can see there that the Wago one on the left has actually melted somewhat. See a bit of bubbling of plastic around the edge, so that certainly hasn't escaped without any problem. But again, this is 150 odd amps, 5 or 6 times more than these things are rated to, so not really surprising that they have failed. And you'll also notice the actual wires themselves are getting extremely hot as well, due to the various discolorations on pretty much the entire surface of them. Now this is what's left after the wreckage there, and this is the Wago connector. And as you see, it has melted completely off of the terminals, although the terminals are still intact. They're still 2 wires are still in there. The Wago one has fared slightly better, but of course it has still melted significantly, so it's completely unusable and destroyed. So although it's better, it's certainly not damage free. Bearing in mind though, this was at 150 odd amps, 5 times or more than the things are actually rated for. And you can see the copper wire has gone various different shades due to the reaction with the oxygen in the air. And so this is 2.5mm, so we had 2 of those, and it was equivalent to 5 square millimetre wire actually feeding both of those. And did that, so the weak point was obviously the connectors themselves. So yes, that one is slightly worse, but not by much. And this one obviously melted, and bearing in mind we had to get to ridiculously high currents before we saw any kind of melting or overheating there. So in terms of operation, they certainly seem to be pretty much equivalent, although this one, say, slightly more overheating there once we got to the very high current level. Now in terms of actually buying these things, although you can obviously buy these ones from various places, if you're buying them in the UK, I say Toolstation sell these, they are selling them for pretty much the same price as the actual Wago ones anyhow, so I don't really see much point in buying these other ones because they're pretty much the same price anyway. Maybe if you bought a big pile from China or something, they might be fractionally less. But that's going to apply if you're going to buy sort of thousands of them. If you're going to buy a small quantity, then probably not going to be a huge amount of difference in the price either. And bearing in mind these are not sort of thousands of pounds each or anything, they're relatively cheap items anyway. So that's pretty much that, and I say it's pretty much well stuck onto the wires there, and even if we go in there and try and sort of wrench it off there, it's still pretty well attached to the wires. We've got to basically break things apart before it obviously detaches from those. And the Wago one here, well, that's kind of sort of just melted and congealed onto the wires anyhow, and see there's the back, it's sort of starting to melt through there. So that's pretty much all we're going to do with these things. The other thing I mentioned here, someone in the comments did put on that they're not very good for testing. Well, they are, because this hole here is where you put your test probe in to obviously check whether it's live or whatever, so already built in there. So that's it for this time, and until next time, thanks for watching.